Good morning, my dear Prep 1 students. Hope you are all fine today. In today's lesson, we are going to discuss the last part in the first lesson in geometry, which is geometric concepts. We studied 3 relations between angles, and today we are going to study 3 other relations and solve more examples. So let's go and begin our new lesson.
The first relation that we are going to study today is vertically opposite angles.
And the abbreviation for vertically opposite angles is VOA. We use VOA when we are solving examples, but please, in the complete, don't write VOA. You should write vertically opposite angles. Let's go now and see what are vertically opposite angles. If 2 straight lines intersect at a point, then the measure of each 2 vertically opposite angles are equal. So, if I have 2 intersecting lines, as you can see, resulting from this intersection, I have 4 angles formed. Angle 1, 2, 3, and 4. Here I have 4 angles formed. Each 2 opposite angles to each other are going to be equal. So here, I will have angle BMC equal to angle DMA, since they are both vertically opposite to each other. And also, I'm going to have angle BMD equal to angle CMA, since they are also vertically opposite to each other. So then, when I have 2 lines intersecting, this means that I will have each 2 opposite angles equal in measure. This angle is equal to this one. And also, I will have the other 2 opposite angles equal in measures, which are this angle and this angle. Each 2 opposite angles are equal in measure. And this is the first relation. Let's go now to the second relation. They are accumulative angle. The sum of measure of the accumulative angles at a point equals 360 degrees. Let's have a figure to illustrate what we are saying. As you can see here, I have 5 angles formed. 1, 2, 3, 4, and 5. All those 5 angles are around one point, which is point M, right? So if I add them all together, I should get angles equal to 360 degrees. And those are the accumulative angles. Accumulative angles are angles which are around one point, and their sum must be 360 degrees. Adding the 5 together, I must get an angle which is equal to 360 degrees. The last thing is bisector angle or angle bisector. Simply, an angle bisector is a ray that divides an angle into 2 equal halves. So for example, if I have here angle CAB, and I said to you that AD ray is an angle bisector. So this means that AD ray bisects this angle into 2 equal halves. As a result, I will have angle CAD equal to angle DAB. Those 2 angles are equal because AD is an angle bisector. It divides the angle into 2 equal halves. And this is the last relation. Is it easy? Let's go now and solve examples. In these 2 examples, I would like you to draw these drawings in your classwork copybook. And let's begin. He wants me to find the measure of the following or missing angles. So let's go now for the first one. To be able to answer any type of question finding a missing angle, simply you can go and ask yourself a few questions. The first one is, are they on the same straight line? If they are on the same straight line, so they should sum up to 180 degrees. The second question is, are they resulting from the intersection of 2 lines, so I have vertically opposite angles? Number C, are they accumulative around one point? And if they are accumulative around one point, then their sum should give me 360 degrees. And number D, is there any angle bisector? Asking yourself those 3 questions, it will be very easy to find the missing angle. So let's go now and work for the first figure. I have here angle 48 degrees. And I want to find angle Z, X and Y. As you can see, let's go and ask ourselves, are those 4 angles on the same straight line?
No, they are not on the same straight line. Are those four angles resulting from the intersection of two lines forming VOA?
Yes, exactly.
So, each two opposite angles
Are going to be equal. As you can see here, angle X is vertically opposite to the 48.
So, angle X is equals to 48 and I should write vertically opposite angles beside it. Let's go now and see how can I find the measure of angle Z.
Let's find the relation between angle Z and angle 48 degrees. So let's again go and ask ourselves the four questions. Is angle Z and angle 48 degrees on the same straight line?
Yes, they are on the same straight line.
Which straight line? This one. So now I know that angle Z plus the 48 degrees should give me 180 degrees. I have part of the 180. How can I find the other one, which is Z? Simply, Z is equals to 180 minus 48, which is equals to 132 degrees.
So now I know that this angle Z is equal to 132 degrees. Can I find now angle Y? So let's go again and ask ourselves the four questions.
Is angle Y on the same straight line with angle Z? No. Are they resulting from the intersection of two lines, so I have VOA?
Yes.
Angle Z and angle Y are vertically opposites to each other, so angle Y is equal to angle Z. Angle Y is equal to 132 degrees because it's a vertically opposite angle. I hope it's clear now, Prep 1. Let's go now and solve the second figure. In the second figure, I have here angle 65 degrees, angle X, which I want to find the measure of, and another angle which is 75 degrees. So I have here three angles. Let's go and ask ourselves the four questions. Are those three angles on the same straight line?
Sure, they are on the same straight line. So if I added them together, I should have the sum of 180 degrees. I have two of them, so it's easy to find the other one.
Simply by doing 180 minus 65 plus 75. And don't forget to put 65 and 75 between brackets. Or go and find their sum alone and then make 180 minus this sum.
If you didn't put the bracket, you're going to have a wrong answer. So either you put the bracket or calculate first the addition of 65 plus 75 and then make your subtraction. Here we are going to have X equal to 40 degrees.
Let's go now and have more questions. We said that we have four main questions we ask ourselves about to be able to answer any question. The first one is, are they on the same straight line? The second one is, are they resulting from the intersection of two lines, so I have VOA? Are they accumulative angles? And the last one is there any angle bisector? Remember, an angle bisector divides the angle into two equal parts. And remember also that straight line, I should have the sum of angles equal 180 degrees, and accumulative angle, I should have the sum equal to 360 degrees. So let's go and begin with the first figure now. Very important to read what angle he needs the measure of. So in this question, he wants the angle ACD. ACD. So he needs this angle. So let's go and see how many angles do I have in this figure. I have two angles. Are those two angles on the same straight line? Yes. So their sum should give me 180 degrees. I have part of it, which is 66. Can I find the other one, which the angles he needs? Exactly. 180 minus 66. I will have an answer of 114 degrees. So angle ACD is equal to 114 degrees. Let's go now for the second one.
I want to find the measure of angle DCE. Angle DCE. This angle. Let's go first and see how many angles I have here. I have 3 angles. Are they on the same straight line? Yes. So, if I add them together, I should get the sum of 180 degrees. And those two signs here means that those two angles are equal in measure. Now, if I'm going to make 180 minus 116, then I'm going to find the angle ACE, the whole green angle. And this is the first step I should do. First go and find the whole green angle, which angle ACE, and it's equal to 64 degrees. Now, by knowing that this whole green angle is equal to 64 degrees, I want only part of it. And remember, those two signs mean that the angles are equal. If I know that, if I add them together, I will get 64. So, to have each one of them alone, I'm going to make 64 divided by 2, so each angle is equal to 32 degrees. Always remember that an angle bisector divides the angle into 2 equal parts. And it's not a must to write that CD is an angle bisector. It's only enough to have a sign, just like those two, draw to tell me that those two angles are equal. Let's go now for the third figure. He wants to find the angle ACD, so he is looking here for this angle. How many angles I have? I have 3 angles. So the first question is, are they on the same straight line? Yes, they are. But remember that those two angles are equal. So if I have one of them equal to 50 degrees as written, so the second one also is going to be 50 degrees. Now, since the 3 angles are on the same straight line, so if I add them together, I should get 180 degrees. How can I find now angle ACD? It is the only angle missing on the straight line. So it is easy. Just 180 minus 50 plus 50, and don't forget to put them between brackets to have a correct answer. So, angle ACD is equals to 80 degrees. Let's go now for the fourth one. I want to find the angle, measure of angle FCB. Here is FCB. So, I am looking for the 2 angles together. The 3 angles are on the same straight line, so they should sum up 180 degrees. And remember, those signs put in each one of the angles mean that the 3 angles are equal in measure. I know that the 3 angles, if I add them together, I should get 180. And I want to divide this 180 equally on the 3 angles. As a result, I will have each angle equal to 60 degrees. So, I have here this angle equal to 60 degrees. This one also 60 degrees, and the last one and the third is 60 degrees as well. Remember, you want to find angle FCB, so you want the 2 angles together. To find the measure of the angle required, I am going to make simply 60 plus 60. So angle FCB is equals to 120 degrees. Let's have more questions now. We said that to find a given angle, we should look first, are they on the same straight line? Are they formed from intersecting lines forming vertically opposite angles? Are they accumulative angles? Is there any angle bisector? And remember, angle bisectors divide the angle into 2 equal parts. And if the angles are on the same straight line, then they should sum 180 degrees. And if they are accumulative angles, they should sum 360 degrees. So let's go now and begin. In the first figure, we have here 5 angles formed.
So the first question, are those 5 angles on the same straight line? No, they are not. Are those 5 angles resulting from the intersection of 2 lines forming VOA? No. Are the whole 5 angles around one point or accumulative around one point? Yes, all of them are accumulative around point M here. And please, I would like you to remember that this sign means that this angle is equal to 90 degrees. Since the 5 angles are accumulated around them one point, so
Accumulative angles should sum up to 360 degrees.
from the 5 angles I have 4 angles. So I have 4 angles and only this angle is missing. And this is the angle he's looking for, angle CMD. It's so easy to find it since I know that the 5 together should sum up to 360. 360 minus the addition of the 4 angles. And don't forget to put them between brackets to have a correct answer. As a result, angle CMD is equals to 123 degrees. Did you get the point now, Prep 1? Asking the 4 questions would make it so easy for you to find which one you're going to use. So let's go now for the second figure. We are going to ask ourselves how many angles are formed. We have here 3 angles formed. Are those 3 angles on the same straight line? No. Are they resulting from the intersection of 2 lines forming VOA or vertically opposite angles? No. Are the 3 angles around one point? Yes, they are all around point M. And also, having this sign means that the 3 angles are equal. So they are all around one point, so they should sum up to 360 degrees, and the 3 of them is equal. Can I find the measure of each one of them? Yes, it's easy. 360, I am going to divide it equally on 3 angles. So each angle is going to be equal to 120. He wants to find the measure of angle AMC. AMC. So he's looking only for one angle. And we said that one angle is equal to 360 divided by 3, which is 120 degrees. Let's go now for the third one. How many angles is formed here? 1, 2, 3, 4, 5 angles are formed. Are they on the same straight line? No. Are they resulting from the intersection of 2 lines forming vertically opposite angles? No. Are they all around one point? Yes, they are all around point F. So, all the 5 angles, when I add them together, I should have the sum of 360 degrees. And remember that those 2 signs means that those 2 angles are equal. Which angle he is looking for is EFD. EFD. So he's looking for this angle. How can I find it? I have 3 angles out of the 5 angles. So first I'm going to work to have the measure of this whole angle together. How can I find it? It's so easy. All of them should sum to 360 degrees. I have 3 of them, so it's easy to find the other. I'm going to make 360 minus 130 plus 70 plus 60, and don't forget to put them between brackets. So I will have angle equal to 100 degrees.
What is the angle which is equals to 100 degrees? It is all this angle. I want only to find part of it, but the 2 parts are equal. So simply I'm going to make 100 divided by 2. So each one of those angles is equal to 50 degrees. So angle EFD is equal to 50 degrees. Let's go now for the last one. We want to find angle DAE. DAE. So I'm looking here for this angle. I have 1, 2, 3, 4. And again, remember that this symbol or this sign means that this is equal to 90 degrees. Are those 4 angles formed on the same straight line? No.
Are they formed from the intersection of two lines having vertically opposite angles? Again, no. Are they all around one point? Yes, they are all around point A. So, if I add them together, I should have 360 degrees. I have 3 angles from the 4 angles. Is it easy now to find the 4th angle which is looking for? Yes, it's so easy. Just the measure of the accumulative angles, which are 360 degrees, minus, open a bracket, 120 plus 80 plus 90. As a result, I will have angle ADE equal to 70 degrees. I hope it's easy now, prep 1. We just need to know the 6 types of relation to be able to solve any question. And remember, to be able to find a given angle, I should ask myself, are they on the same straight line? If yes, then they should sum up to 180 degrees. The second question is, are they resulted from the intersection of two lines, so I have VOA? If yes, then each two opposite angles are equal in measure. Number C, are they accumulative angles? Meaning that they are all formed around one point, and know that the accumulated angles, their sum is equal to 360 degrees. And the last question is there any angle bisector dividing the angles into 2 equal parts?
If you have those 4 questions in your mind while you are answering to find the value of
an unknown angle, it will be so easy to find which one of them you're going to use. We have reached the end of our lesson today. I would like to thank you all, Prep 1, and have an awesome day.